This video is the homework on page 452, and one of these problems I asked you to do by hand, and the other ones we're doing with a calculator. I'm just going to do a couple of these just to kind of make sure you're on the right track. I particularly wanted to take a look at number 14, which is the problem that I asked you to do without a calculator. So let's look at that one first. In this problem, you're given y equal to x squared, and you're given y equal to 6 minus x. And in this particular problem, they've already drawn or given you the graph, and the graph looks something like this. There's the parabola. And then 6 minus x looks something like that. So that's what the graph looks like. You have a parabola intersecting a line. And in this problem, they ask you to find the area bound between those two curves in terms of x as well as in terms of y. Now, doing the problem in terms of x is pretty easy because in this case there's clearly a top curve, which is the line, and a bottom curve, which is the parabola. However, let me just undo what I just did. When we're doing the problem in terms of y, I want you to notice something. First of all, we're going to have to solve each of the equations for x. So I get x equal to plus or minus the square root of y. And then when I solve the second equation for x, I'll get x equal to, let's see, y minus 6, and then divide by negative, so 6 minus y. So those are my two equations solved for x in terms of y. Now, when you're doing the problem in terms of y, notice that we're going to start the collection of area down here at 0. And then we're going to collect the area all the way up into, whoops, get rid of that, all the way up to this point of intersection right here. Because in that region, the right-hand curve is the positive side of the square root of y, and the, let's change colors here, the left-hand curve is the negative side of the square root of y. So the first thing that we need to do is find that point of intersection, the y value. So I'm going to set the square root of y equal to 6 minus y. I'm going to square both sides, and I get y equal to 36 minus 12y plus y squared. So that'll give me y squared, subtract, that'll give me minus 13y plus 36 equal to 0. And when I factor that, I'll get y, 9, 4 minus minus. I get y equal to 9, and I get y equal to 4. So this value right here is y equal to 4, and this value up here is y equal to 9. So when I set up my definite integrals here to collect all of that area, the first integral will start at a lower bound y value of 0. So that's right here. That's where I'm going to start the collection of area, and then I'm going to stop at 4. So I'm going to go from 0 to 4. The right-hand curve, as I pointed out, or as I stated, is the positive side of the square root of y. So that's the right-hand curve, minus the left-hand curve, which is, as I also said, the negative side of the square root of y. So that's going to be, go back to red, minus the negative side of the square root of y, dy, plus, I'm going to collect the area now starting at 4, going to 9, and in that particular region, the line is on the right-hand side. So I'll have, in terms of y, right-hand side 6 minus y, minus the left-hand side, which in this case is the left side of the parabola. So I have minus square root of y, dy. Now when I go to actually do the problem, when I do the math, I will have the integral from 0 to 4. I'm going to change that into y to the 1/2 plus y to the 1/2, negative, negative, of course. And then I'll have plus 4 to 9 of 6 minus y plus y to the 1/2 power. I'll carry it another step or two, and then I'm going to go on to something else. 0 to 4, 2, y to the 1/2. The second integral, nothing combines. 4 to 9, 6 minus y plus y to the 1/2 power dy. Now what I would do in that next step is I would pull the 2 out, and I would have 2. I'm going to find the antiderivative, so that's y to the 3/2 2/3 from 0 to 4. Let me move this out of the way, get it up here, plus 6y minus y squared over 2 plus y to the 3/2 2/3 from 4 to 9. And then I would do my calculations. It's not going to be too bad because both 4 and 9 are perfect squares, and that's going to make it easy to deal with that 3/2 power. But I did want you to see how to do number 14 in terms of y. All right, let's go on and pick out one that we're doing with the calculator, just so I can make sure you understand how to deal with the calculator. If I have my homework written down correctly, it's 31 to 41, and then I have 42 and 51. Let's do, they're all fairly similar. Let's do number 39, just because in terms of typing that in, it might give us more of a challenge. So in number 39, I'm going to write it over here because I'm getting ready to pull my calculator up and I don't want it to get in my way. So number 39, I'll have f of x is equal to 1 over 1 plus x squared, and then g of x is equal to 1/2 x squared. All right, so let me pull my calculator up because this is a calculator problem. And so I have 1 divided by, now make sure you put the denominator in parentheses, so 1 plus x squared, close your parenthesis, and then the second one, instead of putting in 1/2, I'll put in 0.5 x squared. I'm going to start with a Zoom 6 viewing window. Okay, now what I might do, since that region is small, is use the feature that I showed you in class the other day, Zoom box number 1. I'm going to box up that region where the intersection occurs just so I can get a better view of that. I could change the window, but I just think this is easier. I want that point of intersection in there. So that's my first corner of the box, so I press enter. I'm going to arrow down to make sure that I collect everything that I'm going to go a little bit below the x-axis, and then over to the right. Hopefully my point of intersection is in there. I think it is. And then once I set my window, enter, and it's going to zoom in that region. Okay, that gives me a little better view. I can see that the rational function is on top and the parabola is on the bottom. So I'm going to find the first point of intersection by going second, calc, number 5. Arrow over to the first point of intersection, or closer to it anyway. Okay, my cursor's still moving there. All right, so enter, enter, enter. And that's my first point of intersection, which turns out to be a nice integer, so I could have done that by hand, but this is a calculator part. So then I'm going to store that. So second quit. Let's get rid of all this stuff. And then we're going to store. We're going to store. Got to hit it. Store in alpha A. And so that value, that -1's been stored in alpha A. I'm going to go back to the graph. I'm going to go second calc again and find the second point of intersection. Now since this, both of these functions appear to be even, yeah, they're even, then it should be 1, but just for the sake of practicing, we'll go and get the other point of intersection. As soon as my cursor stops, enter, enter, enter. And voila, the second point of intersection is 1. So I'm going to again go back, second quit, to go to the home screen. I'm going to store, and I'm going to put this in alpha B, enter, and I stored that in 1. Okay, now we're ready to do the integration. So I'm going to go back and just take a look at my graph, and I can see that I'm going to be finding the definite integral from -1 to 1, because you want to write your integral down. We said the curve that is on top, we're doing this function in terms of x, is f of x, And the function that is on the bottom is g of x dx, which is the same thing as negative 1 to 1 of 1 over 1 plus x squared minus 1/2 x squared. And we're not doing this problem by hand. So here we go. So second quit, math, number 9. And let's see, I've got to make sure I know where my curves are typed. My rational is in y1 and my parabola is in y2. So I'm going to call up the first function, bars, y bars, function, the rational, minus bars, y bars, function, minus the parabola, which is in y2, comma, in terms of x, comma, from negative 1 to 1. And let the calculator do its job. And we get an area of 1.237. Okay, so that's how you do the problem with the calculator. Not going to do any more of those because literally the rest of these are doing the problems with the calculator. Just trying to see if there's anything else. 42 might be an interesting one to look at. Let me just take a look at that one real quick and then we'll call it a day. Number 42 is y equal to x times the square root of, this is a kind of a crazy problem, 4 minus x over 4 plus x, and then we have y equals 0, which is the x-axis, and then we have x equal to 4. Now we're not going to be able to graph. There is a way to graph a vertical line, but not as a y equal to. So we're just going to have to kind of keep in mind that it's y equal to 4. So let's just see what this thing looks like. Let me get rid of this and get rid of this. All right, go down here. So I have x, and then we have second square root of, put the numerator in parentheses, 4 minus x, divided by the denominator in parentheses, 4 plus x, close, close, and then we have y equal to 0. Now that is the x-axis, but we want to officially graph it, so I'm going to put it in, and let's see what this thing looks like. Okay. It looks like the graph is intersecting at x equal to 4, which makes sense because if we let x equal to 4 in the numerator, we get 0. So the x equal to 4, we can box that up if you want. So let's just get my points of intersection real quick. Second calc, number 5. That looks like it's going to be 0, 0, but we'll just make sure. And the intersection is 0, so I know that I'm going to find the integral from 0, and the other value I think is 4, but we'll just make sure. Second calc, 5, and come on over there. He's still moving, still moving, still moving. Okay, we've got him off the curve now, so I'm going to have to pull him back a little bit. All right, enter, enter, enter. Go to quiz, sign change. All right, so I know that even though the calculator's yelling at me that intersection, or the area is going to stop at 4 because they bounded us at x equal to 4. I also know that if I substitute 4 in place of x here, I'm going to get a 0 in the numerator, which is going to make the entire, so I know it has to be 4. So 0 to 4, the graph is x square root of 4 minus x over 4 plus x dx, and we're going to let the calculator handle this. So I'm going to do math, You know what? I don't do this very often. Let's go back and do it on the graph. So we're going to do the graph, second calc, number 7, which is definite integral, from 0 to 4. I wonder if the calculator is going to yell because I'm trying to use 4. Let's see if he... Oh, nope, he's happy. So we get an area of 3.434. So, easy enough. You just have to kind of be careful typing that in a calculator. If you have other questions, I mean, this is just a sample of the problems that we did in the homework, but I think they're a pretty good representative sample of how we're using the calculator to calculate the area and what the strategies are. If you have more questions, please come and see me.